Hi, I'm Derek Horn, the Application Frameworks Evangelist at Apple. iPhone is running the most advanced mobile operating system in the world. It's a full-featured computer running an operating system that's derived from macOS 10.5 that fits in the palm of your hand. But this is just the beginning. In this video, I'll give you an overview of the operating system that runs on the iPhone and iPod Touch and explain how to write iPhone applications. I'll start off by talking about the available programming languages, and then get into some details about design patterns, as well as the coding and naming conventions we use throughout the development frameworks. And then I'll tell you about UIKit. UIKit is the core application development framework that you'll use to write native applications for the iPhone and iPod Touch. So let's get started. There are a few things you'll need before you can start writing and building native iPhone applications. You'll need a Mac, really any Intel Mac running macOS 10.5. You'll also need the developer tools. Developers have been using our Xcode integrated development environment for many years to develop applications for the desktop, and now version 3.1 allows you to build iPhone applications. And of course, you'll need an iPhone or iPod Touch to run those awesome new applications. As I mentioned, the operating system on iPhone is derived from macOS 10.5, and like macOS 10, it provides a rich set of frameworks to use. At its heart is the core OS, including its Unix underpinnings, so low-level POSIX APIs like printf and TCP networking are available. But the real exciting parts are delivered in Cocoa Touch, our modern application development framework. Developing for the iPhone is very similar to developing for the desktop. Applications are built in Xcode using our object-oriented frameworks and delivered as application bundles with subfolders complete with localized resources. So what is Cocoa Touch? Well, strictly speaking, Cocoa Touch refers to the combination of two frameworks, UIKit and Foundation, and together they refer to the full-featured object-oriented frameworks which allow you to quickly develop iPhone applications. Not only does Cocoa Touch allow you to quickly develop elegant touch-based user interfaces, it also provides gesture support and access to robust application behaviors. Because the object-oriented framework provides a wealth of base behaviors, it allows you to very quickly come up to speed and write simple applications. But at the same time, there are literally thousands of APIs you can use to create almost any application you can think of. The Cocoa Touch framework APIs are written in a modern, object-oriented C-based language called Objective-C. If you're not familiar with Objective-C yet, let me give you a quick overview. The Objective-C language is basically a slim superset on top of ANSI-C with some syntax extensions to allow for object-oriented programming. One of the nice features about the language and its runtime is that it's dynamic, so you can add methods and extend existing classes at runtime. Because it's based on C, there's absolutely no problem integrating C and C++ source and libraries into your own application. Now, Objective-C++ sounds like a new language, but it really isn't. All it means is that you're mixing C++ and Objective-C in the same file. Typically, your files will end in a .mm extension, but you can override that if you need to within Xcode. In the macOS 10.5 runtime, we unified the Objective-C and C++ exception model, and now we brought that latest modern runtime to the iPhone so that you can throw and catch exceptions across language boundaries. Again, with Objective-C 2.0, you see where we have taken the most modern innovations made on the desktop and applied them to the iPhone. The two main ideas behind Objective-C 2.0 were to create a high-level language syntax to access properties through a familiar dot notation, and also to reduce the amount of code that you need to write. We do this by automatically synthesizing and generating getter and setter accessor methods for you. Objective-C is easy to pick up, and we have a great document available online called the Objective-C 2.0 Programming Language. So in order for you to better understand the syntax of Objective-C, let me show you an example. Let's start with a typical C-based function call and see how we'd rewrite it using the Objective-C syntax. Here's a call to set the dimensions of a sticky note. Because we use a descriptive function name, I have a pretty good idea that we'll need to pass in a pointer to our sticky note and some dimensions. But I'm not really sure what that last Boolean is for. Maybe it's to make it visible. Now, if we were to rewrite it using Objective-C, we'll first start by enclosing the call in square brackets. Those square brackets are one of the few extensions Objective-C makes to the C syntax I mentioned earlier. Remember that we're talking about an object-oriented language here. So most of the calls we make are in the form of sending messages to objects. So now we'll need to add our sticky note object. This is the object we're going to send messages to. Here we name our parameters, and these names actually correspond to the function name. So this method is actually referred to as setWidth, height, animate. And now we add the actual arguments. Now, one of the real nice things about Objective-C is that we name our parameters, which makes reading code much easier. As you can see, we're going to set the width, height, and that last mysterious Boolean actually means that we're going to animate our transition. One of the real strengths of the Objective-C framework is how all the frameworks use the same coding conventions. And those coding conventions are building blocks for other concepts. This means that as you learn these conventions, it makes it very easy to adopt and integrate new technologies into your application. For these reasons, it's important that your development follow the same design patterns and coding conventions. The development frameworks are object-oriented, so you should be familiar with object-oriented concepts like subclassing, delegation, and inheritance. We use the model view controller design pattern pervasively throughout the frameworks. That pattern makes a lot of sense, leverages high code reusability, and it's important that your code follow the same MVC pattern. On the view side, we have what's displayed on screen. This is where you design your user interface, where you need to ask yourself, what's the best user experience I can offer users on the iPhone, and how will they interact with my data? The controller handles actions and passes information between the view and the model, which you can consider to be the engine of your application. We provide a number of built-in controller classes, like UI View Controller, which really help guide you to follow this pattern in your own code. Then, the model is the engine of your application. It represents how you manage, manipulate, and store your own data. You'll use Objective-C to interact with the system at the UI layer, but you have a choice of using C, C++, or Objective-C in your own model code. Now I'd like to discuss some coding conventions. Naming and coding conventions are an important part of developing applications using Cocoa Touch. Other technologies depend on you following these conventions. So simple conventions, such as the names you give your getter and setter accessor methods, become building blocks for higher level abstractions. And once you break the initial building blocks, your whole foundation can come falling down. As you learn these conventions, reading, writing, and understanding code will become second nature. In the earlier days of development, abbreviations were common. But the names you'll find in Cocoa Touch frameworks are expressive, clear, and often describe something about the class they're used in. Take the class UI Image View, for instance. By looking at the class name, I automatically know quite a bit about it. The UI prefix tells me it's a class within the UIKit framework. Image indicates that the class works with UI images. And View tells me it's a subclass of UI View. If you look inside the UI Image View header file, you'll see that it has a property named Animation Images. So again, based on the naming conventions used throughout the frameworks, this single name tells me quite a bit about how to use it. I know that the class implements two accessor methods, a getter accessor with the same name as the property itself, Animation Images, and a setter called Set Animation Images. Also notice the property is plural, so I know these methods act on an NS array of UI images. On a side note, the UI Image View is actually a really great view. As you may have picked up, with only a few lines of code, you can create the view and assign it an array of images, and then tell the view to animate between the images. It'll animate them up to 30 frames a second, or you could slow it down to create an easy-to-implement slideshow. Memory management is a crucial part to developing any software application. Cocoa Touch uses a retain, release, reference counting memory management model. This means that if a method returns an object to you, and it's one that you want to reference later, you need to retain it. Once you're done with it, you have to call release, or your application will leak. Okay, now that you've heard about coding conventions, let me tell you a little bit about the options you have in designing your application. When you need to customize behavior of a framework class or control, I think the immediate response is to subclass it. But subclassing often causes you more work in other parts of your code, so you should first look at alternatives before immediately subclassing. Cocoa Touch uses a delegation design pattern. Delegation is the simple yet powerful concept of handing a task over to another part of the program. This allows you to override common behaviors by supplying a delegate method and not having to override. Application did finish launching is a common application delegate where you can hook in and initialize your application. Categories allow you to extend the functionality of an existing class by attaching methods to it. For instance, if you wanted to implement your own encryption and decryption on strings, you might think that you have to subclass NSString and write your own string class that included encryption. But a better way is to tack on your own encryption methods onto the existing NSString class by using categories. Categories apply to methods only. You can't grow the class by storing extra data in instance variables. And of course, you can subclass an existing class to extend or modify its behavior for ultimate control. A great example of where subclassing is needed is with the UI view class. Since all drawing is done in UI views, if you want to create your own view to draw in, you have to derive your custom view from the UI view abstract base class, and then implement your own drawRect method. Now that I've covered some of the concepts behind iPhone development, let's get to the fun part. I'd like to give you a quick overview of UIKit, the framework used to create a rich user experience on the iPhone. UIKit is the framework at the heart of your application. It's responsible for the user experience, multi-touch, intuitive gesture support, managing views, controls, and event handling, as well as driving animation within your application. UIKit leverages concepts from the corresponding framework on the desktop called AppKit. And I'm telling you this because there's a lot of information available about AppKit, and as you bring your application up and have questions, you may find hints or answers by searching for the related information in AppKit references. UIKit provides support for drawing graphics to the screen and handling user interaction through UI windows, UI views, and touch events. It also provides convenience APIs for drawing operations, but for more advanced drawing, I recommend that you use Core Graphics directly. UIKit supplies a number of built-in controls. I love built-in controls. They allow you to quickly create rich user interfaces on the iPhone. Our user interface designers have created a set of intuitive, easy-to-use controls designed specifically for the iPhone. Controls and views like the navigation bar, UI picker, switches, buttons, and table views. And they all have built-in support for touch events, swipes, and finger gestures. As you might expect from Apple, our frameworks offer a very rich media capabilities. UIKit provides an image view, which I mentioned earlier, a web view, an image picker, and makes it very easy to animate your UI. The core animation engine sits on top of the OpenGL ES pipeline for high-performance graphics. Besides OpenGL, there are a number of other media frameworks available, as well as a rich set of audio frameworks built on top of Core Audio. UIKit-based applications are fully localizable. Under the hood, we use the ICU Unicode engine and WebKit to render the text. When the user taps an editable text field, a keyboard is automatically slid into position to receive input, and there are several variants of the keyboard to choose from. So if you just want to accept numbers, you can specify that a number pad be displayed instead. UIKit offers a whole lot more than what I just talked about, and it's just one of the many frameworks available to you. I encourage you to browse the header files inside the UIKit framework and also explore the other frameworks available in the iPhone SDK. And for more in-depth discussion about UIKit, be sure to watch the iPhone Application Frameworks in-depth video, also available on the iPhone Dev Center. And now that you know what it takes to develop iPhone applications, let me tell you about some of the best resources to get answers to your questions. The definitive place to look for developer resources is the iPhone Dev Center, available at developer.apple.com/iPhone, where you'll find the orientation videos, technical documentation, and lots of sample code. I also encourage you to join the self-add mail list targeted at Cocoa developers called Cocoa Dev, available at lists.apple.com. And finally, feel free to contact me at derek@apple.com with any questions you have about developing iPhone applications. So, as you start your iPhone application development, remember, this stuff is fun. With a few lines of code, you'll be able to start writing your own native iPhone and iPod Touch applications. The iPhone is an amazing computer that fits in the palm of your hand. Build something awesome, and I can't wait to start using your iPhone applications.